Eric Burgess here, and we've been given the following equation: 3x minus 4, its absolute value, always less than 2. So we want 3x minus 4 less than 2, and we've got the absolute value. So remember, absolute value is going to take whatever's in here and make it positive. So if we wind up with negative numbers in here, we want those negative numbers to be less than 2. And so for that, that means that say we got like -1, that would be fine because it would become +1, and 1 is less than 2. But say we got like -3. Well, that's not fine because the absolute value will make it +3, and we'll wind up with a 3 less than 2, which doesn't make any sense. 3 is greater than 2. So for the negative case, we want 3x minus 4. We want it to be less than 2. But we also want 3x minus 4 to be greater than -2. In other words, we want 3x minus 4 to be between -2 and 2. Because right, if it's greater than -2, we won't get any numbers that would violate it, like -3 or -4. None of these would come up, making the statement false. And if 3x minus 4 is less than 2, well, that's the original thing we want anyways. Like if we got 1, obviously that's fine. So this is going to be the setup that we'll wind up with. So solving this, we can simply add 4 to each side. So if we add 4, add 4, add 4, we're going to get 2 less than 3x less than, or 2 less than 3x less than 6. And then we can simply divide everything by 3. And we're going to get 2/3 is less than x is less than 2. So what this is saying is that x has to be between 2/3 and 2 in order for our original statement to hold true. And we can test the outermost values, this 2/3 and this 2. And if those two check out, then we should be good to go. Now, it can't include 2/3. Notice that there's not an equals to sign here. So we should check a value somewhere just inside it. But if we actually wind up with 2 when we plug these values in, then we know that the values in between will also check out. So I'm going to check these. So let's go ahead and grab this. And so we're going to do 3 times 2/3. Well, if you look at this, the 3 will cancel with the 3, or it will simplify with the 3, and we'll be left with 2. 2 minus 4 is -2. And we're going to get -2 absolute value. And so we get 2 and 2. So we know that this can't be included, but we do get 2 out. But if we pick a number that's slightly greater than this, because x has to be greater than 2/3, well, let's think about this. Well, 1 is greater than 2/3. So if we pick 1, that's going to be 1 times 3 is 3, minus 4 is -1, and -1 is indeed less than 2. So this gives us evidence to believe that, okay, we've got this done correctly, and we set up our situation, and we didn't make any algebraic mistakes. Now, this also says that x has to be less than 2. Well, if we plug in 2, we're going to get 6 minus 4. Well, that's 2. That's 2 and 2, so we know that that's going to be fine. If there were an equal sign, this would work out. And now, if we plug in something like 1, like we saw earlier, we would indeed be inside the interval. So this would be the correct interval. Now, to write this in interval notation, we would say, well, we'd have parentheses because we've got no equals to on the inequality. And we'd have 2/3 on one side, and we'd have 2 on the other side. And we'd say that x is an element of the interval 2/3, 2. So it's got to be somewhere in this interval, and this would be our answer. If you have any questions about this, feel free to let me know down in the comments. Subscribe. If you're a Citrus College student, stop by online tutoring. We're there to help you out. And we'll catch you in the next problem.